All right. So our last bit about this is going to be synthetic division. So synthetic division is a collapsed version of long division where we only look at the coefficients. So like this here. So what this problem was looking at is like I have 2x cubed minus 3x squared plus 4x plus 5. What I keep is just those coefficients. So I would keep the 2, -3, 4, and 5. Then what we do is this factor here that I'm interested in, x plus 2. So this goes back to those zeros. So if x plus 2 is equal to 0, that would mean x is equal to -2. So what we put out here is that -2. And this one, it's going to be a little odd. One of the things to point out here is the reason we do, like synthetic division is probably going to be the one you prefer to use, but there's a reason we have polynomial division and synthetic division. And that is because I can only use synthetic division if my factors of the form x minus a. So like x minus 1, x plus 3, those are okay. But one of the ones we had earlier was this. This one I can't use in synthetic division. So I'm going to run through an example of how we do synthetic division. So I just want to point out, like sometimes they write it like this before I even do this. So sometimes you might see it as a little bar like this. Either way, it's going to represent the same thing. Okay, we're going to stick with our notation. And we're going to use the elongated L here. So first I'm going to write down all my coefficients. So I have -4. This one is a coefficient of 1, so I have my 1. This is 6, 2, and this is something we didn't talk about before, but what if you're missing something? Like notice I go 5, 4, 3, 2, and then I don't have anything like an x to the 1. So we just sneak in an extra term, which is 0, x to the 1, and then just sneak a 0 in there. But what we know is that this is representing x to the 5th, this is representing x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then essentially which is x to the 0, or just saying that we don't have anything here. No x's. This here is the factor we're dividing by. So if we set that equal to 0 and solve for x, we'd get 2. So that's the number it's going to go out here. So synthetic division works like this. We first drop that first number. Then we take it and we multiply it to this number out here. So -4 times 2 is -8, and we write it here. And then what we're going to do is we're going to just add these. So 1 plus -8 is -7. -7 times 2 is -14. We add here again, I get a -8. -8 times 2 is going to be -16. We add these two numbers together, we're going to get -14. -14 times 2 is going to be a -28. So with that 0, we're just left with -28. -28 times 2 is going to be a -56, plus that 6 is going to leave me with a -6. So sometimes we kind of mark this one off, but this number here at the end, that is your remainder. These numbers over here, sorry, my tool wasn't grabbing. That's going to be your quotient now. So where these numbers up here are representing like the term here, what this does is because I divided by an x, so this was x to the fifth, this should be x to the fourth. So everything goes down a power. So my quotient would be negative 4 x to the fourth minus 7 x to the third minus 8 x squared minus 14x minus 2. And then we have a remainder of 6, or negative 6. So like I said, this is just another way to factor that a lot of times people find a little quicker and easier to do with the synthetic division. So for the next couple problems, so 13, 14, 15, I'll just try to do that by synthetic division again. So this one is telling you the divisor. This one's telling you the 0. So you don't have to do that setting setting your divisor to 0 and solving for it. This one gives it to you already. And then this one we're doing with an I, which I expect to be a little bit of a struggle, but we'll work on that one. Okay, so as a reminder, we have to make sure we fill in all of our x's, x terms. So we x cubed, x squared, that x was missing. So just put a 0x in there and then net minus 5. Then this is the factor we're dividing by. So x plus 3 equals 0 means that x would be equal to negative 3. Sorry, it's not doing the way your book does it. So we put the negative 3 out here, and then we put all of these coefficients here. So 2, 7, 0, negative 5. So like I said, we drop down that 2. So 2 times negative 3 is negative 6. We add the 7 and the negative 6, we get 1. 1 times negative 3 is negative 3, times 0 is negative 3. Negative 3 times negative 3, yes, negative 3 times negative 3 is 9, leaving me with a 4. So we started out with degree of 3, so this is going to be starting out with degree of 2. So that is x, 2x squared plus 1x minus 3, and then my remainder is going to be 4. So this part, just as a reminder, that is the quotient again. Quotient and remainder is 4. So here we wanted to determine if 4 is a 0. So 4 is 0, that means it came from this linear factor. So we don't have to worry about that linear factor part. Essentially what we have is we want to see, is this got that polynomial, and we want to divide it by x minus 4 is essentially what we're doing. But we're going to do it with synthetic division. So my coefficients here is this has a 1, negative 6, 11, and negative 6 again. And then, like I said, we didn't need the linear factor. We were told what this is going to be. It's at 0 at 4. So I drop the 1. 1 times 4 is 4. 4 plus negative 6 is negative 2. Negative 2 times 4 is negative 8. Negative 8 plus 11 is going to be, sorry, it's going to be 3. Right, writing that again. 3 times 4 is going to be 12. 12 and negative 6 is going to just be 6. So we started out with degree 3. So my quotient, like I said, this last number is your remainder. So my quotient is going to be these numbers. So we start, because we had degree 3, we go down a degree. I would be at x squared, or you could say 1x squared, minus 2x plus 3. And my remainder is going to be that 6. So for this one, we are going to factor, we're going to see if I is a 0. So that means, remember, I have a coefficient of 1 here, -3 here. We get 1 again, and -3. So we want x cubed squared to power 1, and then to power 0. So we don't have anything missing. We're going to use I. So we drop down that 1. 1 times I is I, which means this leaves me with -3 plus I. So we're going to multiply that to I. So -3 times I is going to give me -3I. I times I is -1. So that changes it to -1 minus 3I. Well, if we add that to 1, that's going to leave me with just -3I. So -3I times I will end up being, because those i's turn into, it'll be an I squared that turns into a negative. That will just leave me with 3. If I add those together, I get 0. So if we're in the complex numbers, then we see that I is going to be a 0 for us. So that means that x cubed minus 3x squared plus x minus 3, if I factor out a x minus I for that term, then what's left over is everything goes down by a power, right? So this would be x squared. And then we would have plus 3x minus I to the x minus 3I, which I know is a mess, but just to show you, that was how we would factor that out. So we could factor out terms with i's in them as well.